Okay, come, let's look at this TA. Alright. Okay, let's look at question 1A. Solve. Okay, this 1A is quite easy, where they just ask you to solve 3 cosine x equals to 1. So first of all, you need to make cosine x the subject. So it's cosine x equal to 1 over 3. So once you have that, you just do the first step, find the alpha, which is cosine inverse 1 over 3. And what you have is 70, 70.529 degree. Then after that, you need to know which quadrant is this uh, angle x. So cosine x is positive, so it will be the first and then the fourth quadrant. Then now you can solve for x. Okay, the range is from 0 to 360. Okay, so you take the first quadrant, which is 70.529, and the fourth quadrant, which is 360 minus 70.529 degree. And so your answer would be, your solution would be 70.5, round off to 1 dp. Okay, alright, this one is quite easily done. Okay, let's look at A part 2. A part 2. Okay, where you need to solve 2 sine square y minus sine y equals to 0. Okay, how do we solve this equation? Okay, so what you can do is you can let sine y equals to x. So the above equation will look like 2x squared minus x equal to 0. And how do we solve this equation? You can see that there's a common factor of x. So let's take out the common factor x. So it's 2x minus 1 equal to 0. So it's x equal to 0 or 2x minus 1 equal to 0. So once I have my x solution, I can bring back my sine y. So sine y equal to 0 or 2 sine y minus 1 equal to 0. Okay, so this is sine y equals to half. Okay, so sine y equal to 0. So if you look at the sine graph, right? These are the 3 points where sine y is 0. 0 degree, 180, and 360. Okay, so my y would be, okay, my range is 0 to 360. So I cannot include the 0 and 360. So my y is 180. So for this one, I find what's the alpha. So sine inverse half. And that will give me 30 degree. And then the quadrant will be the first and the second. So my y will be first quadrant 30 degree, then 180 degree minus 30, which is 30 and 150. So put it all together, my y solution will be 30, 150, and 180 degree. Okay, all right. So this question is quite easily done. Oh, okay, sorry, I beg your pardon. 0 to 360 inclusive. So you need to include the 0 and the 360. So I beg your pardon. So I need to have 0, 180, and 360. Okay, so my solution would be 0, 30, 150, 180, and 360. So this is my solution. Okay? Alright, let's look at question 2. Solve cosine square x equals to 3/4. Okay. Cosine square x equals to 3/4. So if I were to find cosine x, how do I remove the square? Okay, you can see that you can square root the 3/4. Okay. So that means my cosine x equals to a positive 3 square root 3/4 or a negative 3/4. Okay. So what is my alpha here? Okay. So cosine inverse this is 30 degree. Okay, how about the alpha here? You can see that even though it's a negative square root 3/4, when I find the alpha, it's still a positive 3/4, okay? And it's still the same alpha. So actually, your alpha is the same, all right? And when, okay, so the second step is to find out which quadrant. So for this one, it's positive cosine, right? So it'll be the first and the fourth. Then for cosine x equal to negative square root 3/4, you'll be in the second and the third quadrant. So basically, you need to take your x is in all the quadrant, okay? Because it's first, second, third, fourth is in all the quadrant. So if it's in the first quadrant, it will be 30 degree. The second quadrant will be 180 minus 30, 180 plus 30, and 360 minus 30. And I would have 30, 150, 210, and 330 degree. But you can see that these two angles are out of range because it's from 0 to 180. So this one you reject. So my final answer is 30 and 150. Okay. Okay, this question I already went through in class. Okay, question 4 as well. Okay, let's look at question 5. Yeah, let's look at question 5. Okay, show that 3 plus sine square A over 2 minus cosine A equals to 2 plus cosine A. Okay, so we always work on the side which is the more complicated side. So in this case, it's the left-hand side. Okay, so we start from the left-hand side. Okay, so how do we show that it's equals to 2 plus cosine A? So what we do is, okay, you can see that the sine square A, right? We can do something about it. Okay, let's go back to our identity. Okay, is there any identity we can use? Okay, you can see that there's a sine square A here, which is equals to 1 minus the cosine square A. Okay, let's try that. Okay, let's try that. See whether it works. Okay, so let's replace the sine square with 1 minus cosine square A and see what we have. So after simplifying, I will have 4 minus cosine square A over 2 minus cosine A. So how do we carry on from here? Okay, you can see that this 4 is actually a perfect square, 2 square. And this is also a perfect square because it's cosine square A. So if you recall this identity, A square minus B square equals to A plus B, A minus B. And we try to apply in this context, this would be actually 2 minus cosine A, 2 plus cosine A, right? And you realize that after we do this identity, the 2 minus cosine A will be simplified away because of the common factor, which is equals to right hand side. Therefore, shown. Okay. Now let's look at part 2. Solve the equation 3 plus sine square A, 3 plus sine square A over 2 minus cosine A equals to 1.4. So after, you can see that the part 2 is a continuation from part 1. So in part 1, we have shown that it's actually 2 plus cosine A equals to 1.4. Okay? Because this and this, they are equal. So that means 2 plus cosine A must be equals to 1.4. So my cosine A will be negative 0.6. Okay, so once I have this simple trigo equation, I can go and find my alpha already, cosine inverse. So do I put negative 0.6 or positive 0.6? It must be positive. Okay, it will be 53.13 degree. ASTC, which quadrant is cosine A negative? So it's in the second and the third. So now I can find my A. In the second quadrant will be 180 degree minus the alpha. And in the third quadrant will be 180 degree plus the alpha. So my A will be 126.9. And my second angle 233.1 degree. Okay, let's go to question 6. Okay, another show question. Show that 1 minus, okay, this one definitely have to start from the left hand side. Show that 1 minus cosine 2 theta 1 over 1 plus 2 cosine 2 theta equals to tangent square theta. Okay, so I have a double angle here. So I go to my identity, okay, and see what are my double angle for cosine 2a. Okay, I have three. I have three identity I can use. Okay, let's just copy down the three identities here and see which one is the best for this question. Okay, so cosine 2 theta equals to cosine square theta minus sine square theta, that's 1. Or 2 cosine square theta minus 1. And 1 minus 2 sine square theta. Okay, so which one should I use? Bear in mind that there's a 1 here. Okay, so so which one do we use? So you can see that since there is a 1, and then there's a minus 1 here. Wait. It's minus, right? Since I have 1, if I use this, you can see that my 1 will be removed. Am I right? And then for this 1 plus cosine 2 theta, I have a minus 1 here. So if I use the second identity, my 1 will be gone. Can you see that now it becomes a much simplified? And then the 2 can be simplified away. So I'm left with sine square over cosine square theta, which is actually equals to sine theta cosine theta bracket square. Isn't this tangent square theta? Which is actually a right hand side. Okay, so that means the choice of the identity you use, you must be flexible, you must know why you use certain identity to make it simpler. Okay. Okay, the last question I already went through in class, so yes, that's it. Okay. Right, if you need any other help, please come and see Mr. Liu for consultation. Right.